You've mastered the hardware. Now, let's master the software. This is your complete A+ Core 2 last-minute study guide, covering every objective you need to pass with confidence. The review starts now. Let's break down Objective 1.1, Operating System Types and Purposes. First, what is an operating system, or OS? Think of it as the traffic cop for your computer. It's the essential software that directs all the communication between your physical hardware and the applications you use. It manages your memory, processes input from your keyboard and mouse, handles files, and gives your applications a platform to run on. Now, let's look at the main workstation operating systems. Windows is the market leader. Its biggest advantage is massive industry support for both hardware and software, but its popularity also makes it the #1 target for cyber attackers. Linux is the open source champion. It's free, flexible enough to run on almost any hardware, and supported by a huge community. The downside is that finding drivers for brand new hardware can be a challenge, and there's no central company to call for support. macOS is Apple's closed-source OS. It runs exclusively on Apple hardware. This creates a seamless and stable user experience with strong security. The trade-off is that you're locked in to expensive hardware, and it has less industry support compared to Windows. Chrome OS from Google is a lightweight, browser-centric system based on Linux. It's simple and fast, but relies heavily on a constant internet connection to run its cloud-based apps. Next are the mobile operating systems. iOS and iPadOS are Apple's mobile systems for iPhones and iPads. They are closed source, meaning they only run on Apple devices, and app development is strictly controlled by Apple. On Android, on the other hand, is open source and runs on devices from many different manufacturers. It's maintained by the Open Handset Alliance. Now, let's talk about how an OS organizes data, which is done through a file system. Think of a file system as the library card catalog for your storage drive. It tells the OS exactly where every piece of data is located. Here are the key file systems you need to know. NTFS is the modern standard for Windows, offering features like compression, encryption, and user quotas. FAT32 is an older system that's highly compatible across Windows, macOS, and Linux, but it has a 4 GB maximum file size, which is a major limitation today. exFAT solves that problem. It was designed for flash drives and allows for much larger files while maintaining that cross-platform compatibility. APFS is the Apple file system, optimized for the solid-state drives found in modern Macs and iPhones. And in the Linux world, you'll commonly find ext4, while high-performance Linux systems often use XFS for its ability to handle very large data functions efficiently. Finally, a few critical concepts. First, vendor lifecycle limitations. When a vendor declares an OS as end of life, or EOL, it stops receiving security updates, making it a major risk to use. Second, compatibility. This is a simple rule. Application executables are OS-specific. A Windows.exe file will not run on macOS or Linux. Data files, like documents or images, are usually compatible, and web-based apps work in any browser, making the OS irrelevant. That covers the core concepts for this objective. To recap, the OS is the traffic cop managing hardware and software. Workstation OSs each have trade-offs. Windows has support but is a target. macOS has great integration but is hardware locked. Linux is free but has driver challenges. Chrome OS is simple but needs the internet. Mobile OSs are a split between Apple's closed-source iOS and Google's open-source Android. File systems are the library card catalog for data. Remember the big three for compatibility: FAT32, exFAT, and NTFS. And finally, remember the key compatibility rule: Executables are not interchangeable between different operating systems. Now that you know what an operating system is, let's cover how to install one. This is your rapid review for Objective 1.2, OS installations and upgrades. First, we have to solve the chicken and the egg problem. How do you run an installation program on a computer with no OS? The answer is using a boot method. The most common method today is booting from a USB flash drive that contains the installation files. In a corporate environment, you might use a network or PXE boot to install an OS on many computers at once. Other methods include using an internal recovery partition or even an internet-based installation. When you install, you have two main choices. A clean install is the nuclear option. It wipes everything on the partition and starts fresh. This means backing up your data is mandatory. An in-place upgrade, on the other hand, is a seamless transition. It installs the new OS while keeping all your existing files, apps, and settings. If your OS is corrupted, you might perform a repair installation, which refreshes the OS files but leaves your personal data untouched. In large organizations, technicians use deployment strategies for efficiency. Image deployment is like using a standardized blueprint. You set up one computer perfectly, create an image of it, and then rapidly copy that image to dozens or hundreds of other machines. Before installing, you must prepare the drive. This involves partitioning, which is dividing the drive into logical sections. There are two main partition styles. The older style is MBR, or Master Boot Record, which is limited to 4 primary partitions and can't handle drives larger than 2 terabytes. The modern standard is GPT, or GUID partition table. It's required for UEFI BIOS systems and supports up to 128 partitions and massive drive sizes. After partitioning, the drive is formatted. A quick format is fast, but doesn't securely erase data. A full format is much slower because it writes zeros across the entire disk, making it far more secure. Finally, before any upgrade, you have critical homework to do. First, back up your files. Second, check for hardware compatibility and ensure your applications and drivers will work with the new OS. For Windows 11 specifically, this means verifying your system has TPM 2.0 and Secure Boot enabled in the UEFI BIOS. Also be aware of the product lifecycle. OS vendors release regular quality updates for security and periodic feature updates for new features. That covers the core concepts for this objective. To recap, boot methods like USB and PXE solve the chicken and the egg problem. A clean install wipes everything, while an upgrade keeps your files and settings. Partitioning divides a drive. The modern standard is GPT for UEFI systems, while the legacy standard is MBR. A quick format is fast, but a full format is slow but secure. Before upgrading, always back up your data and check hardware compatibility, especially TPM 2.0 and Secure Boot for Windows 11. Okay, so you know how to install Windows, but which version should you choose? Let's meticulously compare and contrast the Windows editions in your rapid review of Objective 1.3. First, the exam covers Windows 10 set to end support on October 14, 2025, and Windows 11. Remember that Windows 11 features a new user interface, integrates Teams and Copilot AI, and most importantly, it is 64-bit only, dropping all support for 32-bit CPUs. Let's start with Windows Home. This is the consumer baseline. It includes Windows Defender Antivirus, Cortana Voice Assistant, and integrates with a Microsoft account. For networking, it uses a decentralized workgroup, which is like a set of individual apartments, each managing themselves. Home Edition cannot join a corporate domain. For security, Windows 11 Home includes device encryption. For remote access, it can only be an RDP client, and it completely lacks the group policy editor, gpedit.msc. Now, let's upgrade to Windows Pro, the business standard. This version adds the essential corporate toolkit. Most importantly, it can join a domain, which is like a large office building managed from a central security office called Active Directory Domain Services. Pro adds BitLocker for full disk encryption, or FDE. It can act as an RDP host for remote support and includes Hyper-V for virtualization. It also enables group policy. For a single PC, you use the local group policy editor, gpedit.msc. For the whole network, you use the Group Policy Management Console, gpmc.msc. For truly high-end hardware, there's Windows 10 Pro for workstations. This is for power users, supporting up to 4 physical CPUs and the Resilient File System, or REFS. For large-scale deployments, Windows Enterprise uses volume licensing. It adds advanced tools like AppLocker to control applications, branch cache to save network bandwidth, granular user experience control, and in Windows 11, advanced mobile device management, MDM, and mobile application management, MAM. Now for the critical RAM limitations. All 32-bit Windows 10 editions are capped at just 4 GB. For 64-bit systems, the numbers scale up dramatically. Windows Home supports up to 128 GB. Windows Pro jumps to 2 TB. And Pro for workstations and Enterprise support a massive 6 TB of RAM. For encryption, remember the critical difference. EFS, the encrypting file system, can encrypt individual files and folders and is available in all editions. BitLocker provides full disk encryption and is only in Pro and Enterprise. Use the mnemonic BITS. BitLocker is for business. Lastly, remember N versions are for Europe and have no media player, but this can be added back with the Media Feature Pack. Also, for Windows 11, hardware requirements like TPM 2.0 and a UEFI BIOS are mandatory. That covers the critical details for this objective. To recap, Windows 11 is 64-bit only and requires TPM and UEFI. Home Edition uses a workgroup. Pro Edition joins a domain managed by Active Directory. Pro adds the Business Toolkit, BitLocker for full disk encryption, RDP host, Hyper-V, and group policy management. Remember the 64-bit RAM limits. Home is 128 GB, Pro is 2 TB, and Enterprise is 6 TB. Enterprise adds advanced controls like AppLocker, branch cache, and MDM. And finally, BitLocker encrypts the full disk for business, while EFS encrypts individual files for everyone. Now that you know the different editions of Windows, let's dive into the essential features and tools you'll use every day. This is your rapid review of Objective 1.4. First, let's look at the Detectives Toolkit, the tools for gathering information. The System Information Tool, or msinfo32.exe, is like the system's resume. It gives you a read-only snapshot of your hardware resources, components, and software environment. Perfect for a quick overview. For a more dynamic view, use the Resource Monitor, or resmon.exe. This is your system's dashboard with live gauges, showing you exactly how much CPU, memory, disk, and network resources your applications are using in real time. Next, the Control Tower for managing what's happening right now. The Task Manager, which you can open with Control-Shift-Escape, is your primary real-time tool. The Processes tab shows you every running application and lets you find resource hogs. The Performance tab gives you a 60-second graph of your system's resource utilization. The Startup tab is where you can disable applications from launching at login to fix slow boot times. The Services tab lets you start, stop, and restart background services. And the Users tab lets you see and disconnect users who are connected to the machine. For controlling the boot process itself, use System Configuration or msconfig.exe. This is the system's launch sequence controller. Here you can configure safe boot options and manage which services start with Windows. Now for the customizable toolbox, the Microsoft Management Console, or mmc.exe. It starts as an empty shell, and you add snap-ins to build your own toolkit. One of the most important snap-ins is the Event Viewer, or eventvwr.msc, the system's flight recorder. It logs everything happening in Windows, categorizing events as informational, warning, error, or critical. It's essential for investigating past problems. Device Manager, or devmanage.msc, is the hardware roster. It shows all your hardware and lets you manage their drivers. Disk Management, or diskmgmt.msc, is the storage architect's blueprint. Here you can view partitions, change drive letters, and extend or shrink volumes. Performance Monitor, or perfmon.msc, is the long-term data logger. Unlike Task Manager, it can track hundreds of system metrics over days or weeks to help you diagnose intermittent issues. Local Users and Groups, or losermugger.msc, is the security gatekeeper for non-domain computers, where you manage user rights and permissions. Finally, the Maintenance Crew. Disk Cleanup, or cleanmgr.exe, is the system's junk remover, safely deleting temporary files to free up space. Disk Defragmenter, or dfrgui.exe, is like reorganizing a scattered book. It optimizes file locations on traditional spinning hard drives for faster performance. But remember the critical rule. Do not defragment a solid-state drive, or SSD, as it's unnecessary and reduces the drive's lifespan. And the most critical tool of all, the Registry Editor, or regedit.exe. This is the central brain of Windows, a massive database for all hardware and software configuration. It's organized into hives that start with HKEY. Be extremely careful here. Always back up a registry hive before you edit it. That covers the critical details for this objective. To recap, for quick read-only info, use msinfo32.exe. For real-time resource usage, use resmon.exe. Task Manager, Control-Shift-Escape, is for managing active processes and startup apps right now. msconfig.exe is for controlling the Windows boot sequence. The MMC is a customizable frame for snap-ins, like Event Viewer for logs, Device Manager for drivers, and Performance Monitor for long-term tracking. Disk Cleanup removes junk files, and you should only defragment spinning hard drives, never SSDs.
Now that you've mastered the graphical tools, it's time to unlock the power of the command line. This is your rapid review of Objective 1.5, Microsoft Command Line Tools. First, if you ever need help, just type HELP to see a list of commands, or type a command followed by /? for specific instructions. And remember, many of these tools require an elevated prompt, meaning you must run the command prompt as an administrator. Let's start with navigation. To see a list of files and folders, use dir. Think of it as opening a file cabinet drawer. To move between folders, use cd, which is like walking from one room to another. To create a new folder, use md, or mkdir, and to remove one, use rmdir. For copying files, RoboCopy is the robust copy tool. It's like a high-tech mover that can handle huge files and automatically retry if the network drops. Next, disk management. ChickDisk checks your disk's file system for errors. Use the /f switch to fix any errors it finds, and /r to also scan for and recover data from bad sectors. To prepare a new partition, you can use format. And for advanced tasks like creating or deleting partitions from the command line, use the powerful diskpart utility. Now for the crucial network troubleshooting tools. ipconfig shows your IP address, subnet mask, and gateway. Use ipconfig/all to see even more details, like your MAC address and DNS servers. Ping is your go-to tool to test basic connectivity to another device. Netstat, or Network Statistics, shows all active connections. Use netstat-a to see all connections and netstat-b to see which program or binary created the connection. This one requires an elevated prompt. NSLOOKUP lets you query a DNS server to find the IP address for a name. Tracert traces the route, showing you every single router hop a packet takes to reach its destination. And PathPing is even better. It combines ping and tracert to test the connection quality at every single hop along the path. For OS management and information, hostname tells you the computer's name, and WinVer shows you the exact Windows version. WhoAmI tells you the user you're currently logged in as, very useful for checking permissions. GPUpdate forces a group policy update to apply new settings immediately, and GPResult shows you which policies are currently applied to your user and computer. Finally, the System File Scanner, or SFC. If you suspect a core Windows file has been corrupted by malware or a bad update, run SFC/scan now. It will scan all protected system files and repair any it finds that are damaged. That covers the critical details for this objective. To recap, for navigation, use dir to look and cd to move. For disk health, use chickdisk/f to fix file system errors. For network diagnostics, start with ping for connectivity, ipconfig for your own settings, and tracert or pathping to analyze the route. To see which program is making a network connection, use netstat-b from an elevated prompt. To manage group policy, use GPUpdate to force changes and GPResult to see what's applied. And to repair corrupted Windows system files, your go-to command is sfc/scan now.
With the command line covered, let's master the graphical interface by configuring Windows settings. This is your rapid review of Objective 1.6. We'll be looking at two key areas, the classic control panel and the modern Windows Settings app. First, the control panel. Pro tip, switch the view to large icons to see everything. Let's start with Internet Options, the browser's security guard. The Security tab lets you set permissions for different zones, like the Internet or your local intranet. The Connections tab is where you configure a VPN or a proxy server. Programs and Features is your application inventory. Here you can uninstall programs and, crucially, turn Windows features on or off, like adding Internet Information Services, or IIS. The Network and Sharing Center is the network operations room. Go into an adapter's properties, and you can configure its IPv4 settings, like the IP address in DNS servers, or set it to use DHCP. The System applet is the computer's ID badge. It shows your Windows edition and RAM, and under Advanced System Settings, you can configure the virtual memory paging file. The Windows Defender Firewall is your digital gatekeeper, with different security policies for private and public networks. File Explorer Options is critical for technicians. The View tab is where you choose to view hidden files, and, most importantly, uncheck Hide extensions for known file types. Power Options is the system's energy expert. Sweep Mode keeps your work in RAM for a quick resume, requiring a little power. Hibernate saves your work to the storage drive and powers off completely, which is essential if you need to remove the battery. Hibernate is also the technology behind Fast Startup. In these settings, you can also choose what closing the laptop lid does and configure USB Selective Suspend to manage power to peripherals. Finally, Device Manager is the hardware interpreter. It lists all device drivers, and it's where you go to update, disable, or uninstall a driver to troubleshoot hardware problems. Now for the modern Windows Settings app. Time and language is critical in a corporate environment, as correct system time is required for encryption and Active Directory to work. Update and security is where you manage Windows Update. You can configure active hours here to prevent the system from rebooting in the middle of your workday. Privacy settings let you control how much data you share, including enabling or disabling speech recognition services. Devices is the hub for physical connections, including Bluetooth pairing and configuring mouse settings. Network and Internet is the modern equivalent of the Network and Sharing Center, where you can configure your IP and DNS settings. And finally, the Accounts section is where you manage your Microsoft and local user accounts and configure sign-in options like a PIN or MFA. That covers the critical details for this objective. To recap, the control panel is the classic interface for deep administrative tasks. The Windows Settings app is the modern UI where settings are migrating. In Control Panel, use Internet options for proxy settings, programs and features to add or remove Windows components, and File Explorer options to view hidden files and extensions. Power Options distinguishes between Sleep, which uses RAM, and Hibernate, which saves to the disk. Device Manager is your go-to for all hardware driver issues. In the Modern Settings app, use Update and Security to set active hours, and Accounts to configure sign-in options like a PIN or MFA. With the basics of Windows settings down, let's focus those skills on one of the most important areas, networking. This is your rapid review of Objective 1.7. First, let's talk about the Windows Defender Firewall, your computer's digital bouncer. It uses different security policies based on your network's profile. Private for your trusted home or work network, and public for unsecured locations like a coffee shop, which has the highest level of security by default. For granular control, you go into the advanced security settings to create inbound and outbound rules. These rules can be for a specific program, a port number, or a custom configuration, and the key action is to allow or block the connection. Next is client network configuration. Your computer can get its IP address in two ways. Dynamic is the default, where a DHCP server automatically assigns an IP. Static is when you manually configure it. If your computer is set to dynamic but can't find a DHCP server, it will self-assign an APIPA address. Remember the mnemonic always provides internal private addressing. These addresses are in the 169.254 range and can only talk to other devices on the local network. They cannot reach the Internet. To avoid this, you can set an alternate configuration as a manual fallback. When you set a static IP, you need four key pieces of information: the IP address, the subnet mask, the default gateway, your router, and the DNS server, which translates names to IP addresses. Now let's establish some connections. A virtual private network, or VPN, creates a secure encrypted tunnel for your data to travel through an unsecure public network, connecting you safely to a corporate VPN concentrator. For wireless, you need the network name, or SSID, and the security type, like WPA2 or WPA3 with AES encryption. WWAN, or Wireless Wide Area Network, is just your cellular connection. If you're on a corporate network, you might use a proxy server. Think of it as a digital assistant that fetches web pages for you, inspecting them for safety before delivering them. You can configure proxy settings in Internet Options or the Windows Settings app. Resource sharing is a huge part of networking. A workgroup is a decentralized group of computers, like a local neighborhood. A domain, which requires a server running Active Directory domain services, is like a corporate headquarters with centralized management and a single login for all resources.
To access a shared folder on a server, you use a UNC path, which follows the format /servername/sharename. You can make this even easier by creating a mapped drive, which assigns a drive letter, like S:, to that UNC path. Finally, if you're on a connection where you pay for data, like a cellular hotspot, you should enable metered connection settings. This tells Windows to reduce its data usage to help you avoid extra charges. That covers the critical details for this objective. To recap, the firewall uses different rules for private and public networks. If DHCP fails, your PC will get a limited APIPA address in the 169.254 range. The 4-key IP settings are IP address, subnet mask, gateway, and DNS. A VPN creates a secure encrypted tunnel over a public network. A domain provides centralized control via Active Directory, while a workgroup is decentralized. To access shared resources, you can map a network drive to a UNC path, which looks like /servername/sharename. And finally, enable metered connections to save data on cellular or other pay-per-use networks. After mastering the Windows environment, it's time to switch gears and explore the common features and tools of macOS. This is your rapid review of Objective 1.8. First, let's talk about installing applications. Software for macOS often comes in a few key file types. A .dmg or disk image is the most common. Think of it as a virtual CD that you open, and inside you'll often find the applications icon. A .pkg or installer package runs a setup wizard, similar to a Windows executable. The application itself is a .app file, which isn't a single file, but a self-contained bundle, like a suitcase holding everything the app needs. This is why uninstallation is so simple. You typically just drag the app file from the Applications folder to the trash. For verified software, you can also use the Mac App Store, which centralizes installation and updates. macOS organizes its files into a few key system folders. Applications is where your apps live. Users contains the home directory for each user. There are two important library folders. Library at the root contains support files for all users, while the one inside your user folder, users/library, is for your specific settings and is hidden by default. For security and best practices, always use Time Machine, the built-in backup utility. It automatically performs hourly, daily, and weekly backups, and when your backup drive is full, it intelligently deletes the oldest files to make space. While macOS is secure, it's a best practice to install third-party antivirus software. And for updates, you use the Software Update tool in System Settings. Keep an eye out for Rapid Security Responses, or RSRs, which are urgent patches for critical vulnerabilities. An installed RSR is noted by a letter next to the OS version number. Now let's dive into System Settings, the macOS equivalent of the control panel. Here you can configure displays, networks including IP, DNS, and DHCP, and printers. The Privacy section is critical. It's the OS's bouncer, forcing applications to ask for your permission before they can access your location, microphone, or camera. macOS is packed with powerful features. Mission Control, which you can access by swiping up with 3 fingers, spreads out all your open windows so you can easily find anything. Inside Mission Control, you can create multiple desktops or spaces to organize your work. Keychain is your digital safe deposit box, securely storing your passwords, certificates, and private notes, all encrypted with your login password. Spotlight, which you launch with Command Space, is the system-wide search tool that finds files, apps, and even suggests websites. iCloud is the glue that connects all your Apple devices, synchronizing your mail, calendars, and photos. iCloud Drive is its file storage component, similar to Dropbox. And features like Finder, the file manager, the dock for quick app access, and gestures for the trackpad are core to the user experience. Don't forget continuity, the magic feature that lets you start work on your Mac and seamlessly pick it up on your iPhone or iPad. Finally, let's cover 4 essential tools. Use the mnemonic DFTF. Dealing with failure takes focus. D is for disk utility, where you manage storage, format drives, and create partitions. F is for File Vault, the macOS equivalent of BitLocker, providing full disk encryption to protect your data if your Mac is stolen. T is for Terminal, the macOS command line interface. And the second F is for Force Quit. If an app freezes, press Command, Option, Escape to open the Force Quit menu and shut it down. That covers the critical details for this objective. To recap, macOS apps are usually .app bundles installed from .dmg files, and you uninstall them by dragging them to the trash. Time Machine is the automatic backup tool that performs hourly, daily, and weekly backups. Mission Control gives you a bird's-eye view of all your apps and lets you manage multiple desktops. Spotlight, launched with Command Space, is your universal search bar. Keychain securely stores your passwords, and File Vault provides full disk encryption. And if an application hangs, use Command, Option, Escape to force quit. That covers the critical details for this objective.
After mastering macOS, we're diving deep into the powerful world of the Linux command line. This is your rapid review of Objective 1.9. First, the fundamentals. Linux is a free, powerful operating system that comes in many variations called distributions, like Ubuntu or Red Hat. It's supported not by a single company, but by a passionate global community. Think of it like a barn raising, where everyone pitches in. The Linux boot process starts with the BIOS or UEFI, which hands off to a bootloader. The bootloader then starts the kernel, which is the absolute core of the operating system, the CEO managing everything. The kernel then starts a process called systemd, which is responsible for managing all the background services, known as daemons. All major administrative tasks in Linux require you to be the root account, the user with full control. Unlike other OSs, Linux configuration is managed through simple text files, mostly in the etc directory. etc/password lists user accounts, but the actual encrypted passwords are in etc/shadow, a file that standard users cannot read. etc/hosts lets you manually map a domain name to an IP address, and it overrides DNS. And etc/resolve.conf is where you'll find the list of DNS servers your system uses. Now for the essential commands. To get help with any command, just use the man command for manual. For file management, ls lists directory contents. Use ls-la for a detailed view with permissions. pwd prints your current working directory. cp copies a file, and mv moves or renames a file. To delete a file, use rm. To search for text within files, use grep. To find files by name, use find. Permissions are critical in Linux. The chmod command changes file permissions for the user, the owner, the group, and others. You can use octal numbers, 4 for read, 2 for write, and 1 for execute. So chmod 764 gives the user read, write, and execute, the group read and write, and others just read access. To change the file owner or group, you use the chown command, but you'll need elevated rights to do it. For administrative tasks, you need root permissions. It's best practice to use sudo to run a single command with elevated rights. The su command, on the other hand, switches your entire terminal session to the superuser. For installing software, you'll use a package manager. On Debian or Ubuntu systems, you'll use apt. On Red Hat systems, you'll use DNF. For networking, the IP command is your main tool.
IP address will show your IP configuration. Ping tests connectivity, but remember, in Linux, it will run forever until you press Ctrl-C. Use dig for DNS lookups and traceroute to map the hops to a destination. For checking your system status, PS-E will show you every single process running. Top gives you a live, real-time dashboard of your system's performance, including CPU and memory usage. To see how much disk space is free, use df-h for a human-readable view. And to see how much space a folder is actually using, use du-h. To view the contents of a file, use cat. And if you need to edit a configuration file, Nano is a simple, full-screen text editor. That covers the critical details for this objective. To recap, Linux is a free, community-supported OS. The kernel is the core, and systemd manages services. Key config files are in the etc directory, with user passwords hashed in the protected etc/shadow file. Use ls to list files, cd to move, cp to copy, and rm to remove. Manage permissions with chmod using octal numbers and change ownership with chown. Use sudo for single elevated commands, which is the preferred best practice over using su. For networking, use IP for configuration, ping for connectivity, and dig for DNS. For system status, use PS to see processes, top for real-time performance, DF for free disk space, and DU for disk usage.
With the command line under our belts, we now shift to a core technician task, installing applications correctly. This is your rapid review of Objective 1.10. Before you ever click Install, you must act like a detective, checking the application's system requirements. First up is the architecture, 32-bit versus 64-bit. Think of it like a highway. A 32-bit OS is a country road that can only handle about 4 gigabytes of RAM. A 64-bit OS is a superhighway that can manage massive amounts of memory. A 64-bit system can run both 64-bit and 32-bit apps, but a 32-bit system cannot run 64-bit software. A quick mnemonic: in Windows, older 32-bit apps go into the folder with the extra characters, program files x86. Next, graphics. For basic tasks, the integrated graphics built into the CPU is fine. But for demanding software like 3D modeling or video editing, you'll need a powerful, separate, dedicated graphics card with its own VRAM or video RAM. Always check the RAM requirement. And remember, the number listed is just for the app itself. It doesn't include the RAM your operating system is already using. The same goes for the CPU. The required speed, measured in gigahertz, must be met or the application will lag or fail. For some very expensive, specialized software, a simple license key isn't enough. The developer might require a physical hardware token, usually a USB device, to be plugged in for the application to run. This is a powerful form of license control. Finally, ensure you have enough storage, as some applications can be massive. Now, how do we get the software? The most common distribution method is a downloadable package directly from the developer's website. Always download from the source to ensure it's legitimate. For offline systems or complex installations like an entire OS, you might use physical media, like a USB drive or a mountable ISO file. An ISO is a perfect digital copy of a disk. Letting it mount lets the OS read it like a real drive. For large businesses, image deployment is key. This involves creating a perfect clone of a fully configured system, OS, apps, and all, and deploying that image to dozens or hundreds of machines. This is incredibly efficient, especially for virtual machines. But installing an application in a business has a ripple effect. These are the impact considerations. First, an application inherits the exact same permissions as the user who installs it. This gives it access to local files, network drives, and services. A poorly coded or malicious app could cause chaos. Second, a new application can disrupt business operations. A new user interface could slow down workflow for thousands of employees. Because of this, new software is almost always tested in a sandbox environment first to identify and fix problems before they can impact the entire company. To recap, a 64-bit OS can run 32-bit apps, but not the other way around. 32-bit apps are limited to about 4 gigabytes of RAM. Demanding apps need a dedicated graphics card, more RAM, and a faster CPU. Some niche software requires a physical hardware token for licensing. Distribution can be a download, a physical USB drive, a mountable ISO file, or a full system image deployment. Critically, an application inherits all the user's permissions, and new software must be tested in a sandbox environment to avoid disrupting business operations. We've mastered the local machine, but now we move to the cloud, where modern productivity lives. This is your rapid-fire review of Objective 1.11. First, the fundamentals. The cloud replaces on-premises infrastructure with services that are scalable, meaning you can add resources on demand, and highly available, thanks to built-in redundancy and backups. This model delivers a full suite of productivity tools. Email systems are the most common, moving from local Exchange servers to platforms like Microsoft 365 or Google Workspace. Cloud storage like OneDrive or Google Drive offers near-limitless space. Critically, you must configure the client's sync and folder settings. You can mirror everything locally, use selective sync to only download specific folders, or keep files cloud-only to preserve local disk space. These services power the core collaboration tools. This includes shared spreadsheets, live co-authoring and word processing tools, group presentation editing, and team communication through video conferencing and instant messaging, all updating in real time. Managing this requires centralized control. First, identity synchronization. Instead of separate logins for every app, services like Microsoft Entra ID, Okta, or Google Identity create a single source of truth for a user's identity. If you disable a user in one central directory, they lose access to all connected cloud services. It's a single global access badge. Second, licensing assignment. Licenses are no longer physical keys. They're digital tokens managed from a central cloud console. An administrator can view the entire license pool and instantly assign, revoke, and reassign a license from one user to another. This is incredibly efficient and cost-effective, ensuring you never pay for a license that isn't being used. To recap, cloud services are defined by scalability and high availability, replacing on-premises hardware. Cloud storage configuration relies on key sync settings, mirroring, selective sync, and cloud-only. Collaboration tools include real-time editing of spreadsheets, docs, and presentations, plus video conferencing and IM. Identity synchronization services like Entra ID or Okta create one central user profile for all cloud apps. Cloud licensing assignment allows admins to centrally manage and reassign licenses to save costs. We've spent an entire domain learning how to install, configure, and manage operating systems. We've mastered the machine, but now we have to learn how to protect it. Welcome to Domain 2, Security. This is your rapid-fire review of Objective 2.1. Security is divided into two worlds, logical and physical. Let's start with logical security, the rules governing the digital realm. The foundation is Identity and Access Management, or IAM. Think of it as the HR department for digital identities. It manages the entire life cycle of who gets access to what. It all starts with directory services, like Active Directory, which is the central phone book and master key registry for the entire network. To make life easier, we use Single Sign-On, or SSO, which is like a master key card that lets you authenticate once to access multiple applications. For web apps, this is often handled by SAML, an open standard that acts like a digital valet, confirming your identity with a trusted source before granting you access. Now, who gets what power? The principle of least privilege is king. A user or app should only have the minimum permissions necessary to do their job. For high-level accounts, we use Privileged Access Management, or PAM, which locks super-user accounts in a secure vault. A key PAM strategy is just-in-time access, which grants temporary expiring admin rights, preventing an attacker from gaining permanent control. This all fits into the Zero Trust model, a security architecture where nothing is trusted by default. It's like having a security checkpoint at every single door inside the building, not just the front entrance. We enforce these rules with access control lists on routers and within the OS itself. To protect our data and devices, we use Data Loss Prevention, or DLP, a system that stops sensitive data, like credit card numbers, from leaving the network. For phones and tablets, we use Mobile Device Management, or MDM, a central console that can enforce security policies and, critically, remotely wipe company data from a personal device if an employee leaves. To prove we are who we say we are, we use multi-factor authentication, or MFA, which requires more than just a password. The factors are something you know, a password, something you have, your phone, something you are, a biometric, or somewhere you are, your location. Common methods include an authenticator app that generates a time-based one-time password, or TOTP, a physical hardware token, or a code sent via SMS or voice call. Though be warned, SMS and voice are vulnerable to SIM swapping attacks. Next, physical security, protecting the actual hardware and facilities. This starts at the perimeter with fences and bollards to stop vehicles. To enter, you might pass through an access control vestibule or a man trap, which ensures only one person enters after being verified by a security guard. Lighting is a critical, simple deterrent. Magnetometers detect metal, and alarm systems use motion sensors to detect intruders. For access, we've moved beyond simple keys. Now we use key fobs, smart cards, or even a mobile digital key on our phones. To protect servers, we use equipment locks on the server racks themselves. The strongest proof of identity is biometrics. This isn't a photo, it's a digital map of a unique physical trait. A retina scanner, which reads the capillaries in your eye, is one of the most accurate. Fingerprint scanners and facial recognition technology, which creates a 3D map of your face, are also extremely secure. Palm print and voice recognition exist, but are generally considered less secure. To recap, logical security is about access rights. Key concepts are IAM, SSO, SAML, and the principle of least privilege. The modern approach is the Zero Trust model. MFA strengthens logins by requiring multiple factors, like something you have, an app generating a TOTP, and something you are, a biometric. Physical security protects facilities. It starts with perimeter controls like fences and bollards and uses layered access like vestibules and security guards. Modern physical access relies on tokens like smart cards and key fobs, with biometrics like retina scans and FRT providing the highest level of authentication. After covering the high-level theories of security, it's time to get our hands dirty inside the operating system. We're now configuring the basic security settings in Microsoft Windows. This is your rapid-fire review of Objective 2.2. First, the built-in defenses. Microsoft Defender Antivirus is your front line, enabled by default.
You manage it in the Windows Security app, where you can activate or deactivate real-time protection, and most importantly, manually update the virus definitions or signatures to protect against the latest threats. Paired with this is the Windows Firewall, which you can activate or deactivate to control network traffic. You can configure port security to open or close specific ports and set application security rules to allow or deny internet access for specific programs. Next, user access. Windows has local accounts and cloud-synced Microsoft accounts. Within these, you have account types: administrator with full control, and the standard account for daily work. You should always use a standard account and only elevate your privileges when necessary. Windows offers many modern login options beyond a password, including a PIN, fingerprint, or facial recognition via Windows Hello. When you do need to perform an admin task from a standard account, you'll encounter the User Account Control, or UAC. Think of UAC as a security guard that stops you and asks for admin credentials before allowing a system-wide change. To trigger this intentionally, you right-click an app and choose Run as Administrator. File access is governed by two sets of rules: NTFS and Share Permissions. NTFS permissions are applied locally to the file or folder. Share permissions are only applied when accessing that file over the network. The golden rule is the most restrictive permission wins. If NTFS gives you full control, but the share permission only allows read, you only get read access over the network. Permissions also have inheritance, flowing from a parent folder to its children, but an explicit permission set on a file will always override an inherited one. For data protection, we use encryption. BitLocker is a full-disk encryption tool that scrambles the entire operating system volume. If the drive is stolen, the data is unreadable. BitLocker To Go extends this protection to removable USB drives. For more granular control, you can use Encrypting File System, or EFS, which encrypts individual files and folders, tying them directly to your user account credentials. Finally, in a corporate environment, all of this is managed by Active Directory, the master key registry for the entire network. A computer must first join the domain to be managed. Inside AD, we use organizational units, or OUs, to group users and computers, like different departments in a building. This is crucial because we apply group policy to these OUs. Group policy is how we enforce settings across the network, like assigning login scripts, creating private home folders for users, or using folder redirection to automatically back up a user's desktop and documents to a server. When you make a group policy change, you can force it to apply immediately with the command gpupdate.force. To recap, Windows security relies on the built-in Defender antivirus and firewall. Keep Defender's definitions updated. User Account Control, or UAC, is the gatekeeper that requires admin rights for system changes. For file access, the most restrictive setting between NTFS and Share always wins. BitLocker provides full disk encryption for main drives and USBs, BitLocker To Go, while EFS encrypts individual files and folders. Finally, Active Directory is the central management database. We use group policy applied to OUs to enforce settings and can push immediate updates with gpupdate.force. We've locked down the operating system, but how do we protect our data when it's flying through the air? We're now diving into wireless security. This is your rapid-fire review of Objective 2.3. First, let's talk about authentication in a corporate environment. Instead of each Wi-Fi access point having its own password list, companies use centralized authentication servers. This is called the AAA framework. Authentication, proving you are who you say you are. Authorization, defining what you can access. And accounting, tracking your activity. The most common AAA protocol you'll see is Radius, the Remote Authentication Dial-In User Service. Think of Radius as the main gatekeeper. Your Wi-Fi, VPN, and switches all call the central radius server to verify your credentials. A similar but less common protocol, heavily associated with Cisco hardware, is TACACS+. Inside a Microsoft Windows domain, the king of authentication is Kerberos. Kerberos enables single sign-on, or SSO. It works like a fast pass at an amusement park. You log in once, and the Kerberos ticket granting service gives you a special service ticket. You then show this ticket to all other network resources, like file servers, to gain access without ever typing your password again. It provides mutual authentication, meaning both you and the server prove your identities to each other. Of course, a password alone isn't enough. We need multi-factor authentication, or MFA, which combines different types of factors. These are something you know, a password, something you have, your phone, something you are, a fingerprint, where you are, your location, and something you do, your signature. Now, for the wireless connection itself, we need protocols and encryption. Wi-Fi has evolved significantly. The original was WEP, which was deeply flawed and is now obsolete. The emergency replacement was WPA, which introduced an encryption protocol called TKIP. TKIP was a crucial stopgap because it could run on older hardware that couldn't handle stronger encryption. The long-term standard became WPA2, which upgraded our encryption to the powerful Advanced Encryption Standard, or AES. AES is the strong modern encryption we rely on, but it often required new hardware. The latest and most secure standard is WPA3, which still uses AES, but strengthens the initial key exchange and can even provide encryption on open public networks. Finally, how you connect depends on the environment. For home use, you use a pre-shared key, also called WPA2 or WPA3 personal. This is like the key to your front door. Everyone shares the same password. In a corporate environment, you use enterprise mode, also known as 802.1. This requires a unique username and password for every single user, which is then checked against a central authentication server, usually Radius. This is like using a personal key card tracked by a central security system, giving the company granular control over who can access the wireless network. To recap, centralized authentication is handled by AAA servers using protocols like Radius. In Windows domains, Kerberos provides single sign-on using a ticket-based system. MFA strengthens security by combining different factor types, something you know, have, are, where you are, or do. The evolution of wireless encryption is WEP to WPA with TKIP to the modern standards of WPA2 and WPA3, which both use the strong AES encryption. For authentication, home networks use a single pre-shared key, PSK. Corporate networks use enterprise mode, 802.1, which requires a unique username and password for each user, authenticated by a Radius server. We've built our digital fortress, and now the enemy is at the gates. We're diving deep into the world of malicious software. This is your rapid-fire review of Objective 2.4, Malware. Malware is any software you don't want on your system. Let's meet the most wanted. A Trojan is malware disguised as a legitimate program. You run it, and it secretly opens a back door for an attacker. A virus is code that needs you to run an infected program to execute and spread. A rootkit is the most insidious. It burrows deep into the core of the operating system, hiding its presence from antivirus and even the task manager, making it almost impossible to find. Spyware is a digital private eye that watches your activity. A specialized form of this is a keylogger, which records every single keystroke you make, passwords, messages, everything. Ransomware is digital extortion. It encrypts all your personal files and demands a ransom payment for the key. A boot sector virus is malware that loads before your operating system even starts. A crypto miner secretly steals your CPU cycles to mine cryptocurrency for an attacker. Stalkerware is invasive spyware that can track your location, listen through your microphone, and watch through your camera. And fileless malware is a ghost. It runs entirely in your system's memory, never writing a file to your disk, making it invisible to traditional scanners. Finally, you have adware and potentially unwanted programs, PUPs, which clutter your system with ads and unwanted toolbars. So, how do we fight back? First, our tools and methods. If your OS is corrupted, you'll need the Windows Recovery Environment, which lets you access a command prompt before Windows loads to troubleshoot and repair the system. But the only way to be 100% sure malware is gone is a full OS reinstallation, ideally from a known good image. For detection, we have modern systems that go beyond simple signatures. Endpoint Detection and Response, EDR, uses behavioral analysis on a single device to detect and automatically isolate threats. Managed Detection and Response, MDR, is when you hire a third-party company to manage your EDR for you. And Extended Detection and Response, XDR, is the big picture. If EDR is a camera on your front door, XDR is a citywide surveillance system, correlating data from endpoints, the network, and the cloud to spot widespread attacks. Our standard security toolkit includes antivirus and anti-malware, which must have their definitions updated constantly. An email security gateway scans all incoming mail for threats before it ever reaches your inbox. And a software firewall, like the one built into Windows, is critical. It acts as a personal guard, preventing malware that might be on your system from communicating back to its command and control server. Finally, the weakest link is often the human. User education is the best defense against social engineering. This means regular anti-phishing training to teach users how to spot malicious emails and internal testing to see if the training is working. To recap, malware includes Trojans, disguised apps, viruses, need human action, rootkits, hide in the OS, ransomware, encrypts files, and keyloggers, steal passwords. The only 100% guaranteed removal method is a full OS reinstallation. The Windows Recovery Environment is your pre-boot command line for repairs. EDR, MDR, and XDR are modern detection systems that use behavioral analysis. EDR is for endpoints, XDR is for the whole infrastructure. Your standard security toolkit includes antivirus with updated definitions, an email security gateway to scan mail, and a software firewall to block outbound malicious traffic. The best prevention for phishing is consistent user education and training. We've configured our technical defenses, but the greatest vulnerability is often not in the software, but in the user. We're now exploring the world of social engineering, threats, and vulnerabilities. This is your rapid-fire review of Objective 2.5. Let's start with social engineering, the art of manipulating people. The most common form is phishing, which uses spoofed fake emails to trick you into giving up credentials. This branches out. Vishing is voice phishing over the phone. Smishing is phishing via SMS text message, and QR code phishing uses malicious QR codes to send you to fake sites. A general phishing email is like casting a wide net, but spear phishing is a sniper rifle, targeting specific, high-value individuals. When that target is a C-level executive, it's called whaling. In the physical world, shoulder surfing is simply looking over someone's shoulder to steal a password. Use a privacy filter to stop this. Tailgating is following an authorized person through a secure door. Impersonation is pretending to be someone else, like a repair tech or a VP, often using details found while dumpster diving through company trash to sound legitimate. A common tactic is business email compromise, or BEC, where an attacker impersonates the CEO and emails accounting demanding an urgent fake wire transfer. Next up, the technical threats.
An on-path attack, or man-in-the-middle, is where an attacker secretly sits between you and a server, intercepting your traffic. A common way this is done on a local network is ARP spoofing. On a wireless network, an attacker can set up an evil twin, a rogue access point with the same name as the legitimate Wi-Fi, tricking your device into connecting to them. Always use a VPN on public Wi-Fi to protect against this. Then there are attacks on services. A denial of service attack, or DOS, makes a service unavailable, either by overwhelming it or exploiting a flaw. When this is done using a massive botnet of millions of infected computers, it's a distributed denial of service attack, or DDoS. To get your password, attackers might use a brute force attack, trying every possible combination, or a dictionary attack, which uses common words and phrases. Some of the most dangerous threats are application attacks. A SQL injection exploits a website's database by typing malicious SQL code into an input field, like a login box, potentially bypassing authentication entirely. Cross-site scripting, or XSS, involves an attacker injecting malicious JavaScript into a legitimate website, which then runs in the victim's browser, often to steal their session cookie. A zero-day attack is an exploit for a vulnerability that the software vendor has just discovered and has had 0 days to patch. A supply chain attack is when attackers compromise a trusted third-party vendor to get to their real target, like hacking an HVAC company to get their VPN credentials for a major retailer. And never forget the insider threat, a malicious employee who already has trusted access. Finally, let's talk about vulnerabilities, the weaknesses that allow these attacks to succeed. Unpatched systems are a massive vulnerability. If you miss Microsoft's Patch Tuesday, attackers will create exploits for those known flaws. Similarly, unprotected systems missing an antivirus or firewall are easy targets. A non-compliant system is any device that doesn't meet the company's security baseline. Systems that are end-of-life, or EOL, are the most dangerous, as the vendor no longer provides security updates for them. And the BYOD, or Bring Your Own Device policy, creates a vulnerability by mixing personal and corporate data, which must be managed with an MDM. To recap, social engineering attacks manipulate people. This includes phishing and its variants, vishing and smishing, along with physical tactics like tailgating and shoulder surfing. Common threats include on-path attacks like evil twins, service attacks like DDoS, and password attacks like brute force. Web application attacks like SQL injection and cross-site scripting exploit a failure to validate user input. A zero-day is an attack on a brand new, unpatched vulnerability. A supply chain attack compromises a trusted third-party vendor. Vulnerabilities are weaknesses. The most critical are unpatched systems and systems that are end-of-life, EOL. A user reports their computer is acting strangely. It's slow, sluggish, and popping up with bizarre errors. Your job isn't just to fix it, it's to perform a digital exorcism. Welcome to the malware removal process. This is your rapid-fire review of Objective 2.6. Now, the industry best practice is simple. Nuke it from orbit. Wipe the drive and re-image from a known good source. But what if the user has critical, unbacked up files? That's where this 10-step procedure comes in. Its goal, get the system stable enough to rescue the data before you wipe it clean. Step 1. Investigate and verify. Think of yourself as a computer doctor. Are the symptoms obvious, like a Windows security alert screaming, "Threats found"? Or are they subtle, like a slow boot up or unusual sluggishness? Just like a doctor checking a patient's temperature, you need to recognize both the clear and the hidden signs of sickness. Step 2. Quarantine the infected system. This is critical.
The moment you suspect malware, cut it off from the network. Unplug the Ethernet cable, disable the Wi-Fi. A connected machine can spread the infection to the entire network in minutes. Also, do not use USB drives to move files, and absolutely do not perform a backup. You'll just be backing up the virus. Step 3. Disable System Restore. This might feel counterintuitive, but it's vital. Malware is smart. It often infects your restore points. If you try to go back in time to a clean state, you'll just bring the malware back with you. By disabling System Restore, you delete all existing restore points, including any malware hiding within them. We'll re-enable it later, but for now, we have to burn the contaminated safety nets. Steps 4 and 5. Remediate and update. This is the first attempt at a cure. Your anti-malware software might have already quarantined some files. Go ahead and try to remove them. But immediately after, you must update your anti-malware software. You need the very latest engine and, more importantly, the latest signature files. Think of signatures as an intelligence agency's list of known threats. If your list is outdated, new malware will walk right past your defenses. Step 6. Use advanced scan techniques. What if the malware is blocking your updates or even preventing Windows from starting normally? Time to bring out the heavy tools. First, try booting into safe mode. This loads a minimal version of Windows, which can prevent the malware from running, giving you a chance to scan and remove it. If even safe mode fails, you'll need the Windows pre-installation environment, or WinP. This is a command line environment that lets you access the file system from outside the corrupted OS to repair boot records or manually remove files. Step 7. Re-image or reinstall. You've used WinP to copy the user's critical documents to a safe location. The rescue mission is over. Now it's time to follow the real best practice. Delete everything. Re-image the drive from a known, clean corporate image or perform a fresh OS installation. This is the only way to be 100% certain the malware is gone for good. Step 8. Schedule scans and updates. Now that the system is clean, let's keep it that way. Ensure your antivirus is set to real-time scanning, which constantly monitors activity. Then, schedule regular, deep scans to catch anything that might have been missed. Just as importantly, configure Windows Update to download and install security patches automatically. An unpatched OS is an open door for attackers. Step 9. Enable System Restore and create a new restore point. Remember how we disabled System Restore? It's time to turn it back on. Once it's enabled, immediately create a fresh, clean restore point. This gives you a known good snapshot of your newly re-imaged system to fall back on if you ever have issues in the future. Step 10. Educate the end user. This is the most important step for preventing a repeat incident. The user is the first line of defense. Gently explain what happened and provide simple, actionable security advice. Use posters, login messages, or intranet pages to reinforce best practices. An educated user is the best anti-malware tool you have. To summarize the key ideas, the only 100% guaranteed removal method is to re-image the OS. This 10-step process is for data recovery before you do that. Always remember the critical first action is to quarantine the system. If Windows won't boot, use safe mode or the Windows recovery environment. And finally, after cleaning the system, harden it with updates and most importantly, educate the user.
We've just walked through the emergency procedure for cleaning up a malware infection. But the best medicine is always prevention. So now we're going to shift from being reactive to being proactive by building a digital fortress around our workstations. This is your rapid-fire review of the security options and hardening techniques in Objective 2.7. First, we protect the data itself. We use data-at-rest encryption to make our information unreadable to unauthorized users. The most common method is full disk encryption, or FDE. On Windows, this is called BitLocker. It's like putting the entire hard drive inside a digital vault.
This is especially critical for removable media like USB drives, because when an encrypted drive is lost, you only lose the hardware, not your sensitive data. Next, we strengthen the first line of defense, passwords. A strong password has high entropy, meaning it's unpredictable. To achieve this, focus on 4 things: length, make it 8 characters or more; complexity, use a mix of uppercase letters, lowercase letters, numbers, and symbols; uniqueness, never reuse passwords across different services; and finally, expiration. Passwords should be changed regularly, typically every 30 to 90 days. We can also lock down the computer before the operating system even loads. This is done with BIOS or UEFI passwords. A supervisor password prevents changes to the firmware settings, while a user or boot password stops the computer from starting up until the correct password is entered. Now let's talk about the user, who is often the weakest link. End-user best practices are critical. Always use screensaver locks that require a password after a period of inactivity. Manually lock your machine whenever you step away. For hardware, use physical cable locks to secure laptops and prevent theft. When it comes to sensitive data like personally identifiable information or PII, be aware of your surroundings. Use privacy filters on your screen to block shoulder surfers, and always shield the screen when entering passwords. To manage all these unique, complex passwords, use a password manager. It's an encrypted vault for all your credentials, secured by a single master password. Beyond the user, we need robust account management. This starts with the principle of least privilege. Only give users the absolute minimum permissions they need to do their job. Don't give everyone the master key to the vault. We can also restrict login times to specific business hours and set up failed attempts lockout, which freezes an account after too many incorrect password tries. For temporary staff, always set account expiration dates so their access is automatically revoked when their contract ends. And of course, always disable the default guest account. Finally, we apply system hardening techniques to reduce the attack surface. The moment you set up a new device, change the default administrator account and password. Attackers have lists of these defaults. Next, disable auto run. This dangerous legacy feature automatically ran programs from USB drives and has been disabled in modern Windows for a reason. Lastly, every program running in the background is a potential vulnerability. Go through your Windows services and disable any that are not being used. To summarize, Workstation hardening is about protecting the data with encryption, controlling access with strong password policies and smart account management, and locking down the system by changing the defaults and disabling unused services. We've locked down our desktops and laptops, but in today's world, the most critical data often lives on the powerful computers we carry in our pockets. Securing mobile devices requires a unique set of tools and policies. This is your rapid-fire review of Objective 2.8. First, let's harden the device itself. Just like with workstations, we start with device encryption. This scrambles your data, making it unreadable if the phone is lost or stolen. On modern phones, this is usually on by default, and your passcode or PIN acts as the key. Think of it as a locked safe for your data. Even if someone steals the safe, they can't get what's inside. Next are screen locks. You have several options: biometrics like facial recognition or a fingerprint, a numeric PIN code, a swipeable pattern, or a simple swipe, which is the least secure. To stop attackers from guessing your code, mobile devices have failed login attempt restrictions. For example, after 10 failed attempts, an iPhone can be set to erase all data completely, which is why a good backup strategy is critical. Just like workstations, mobile devices need constant maintenance through patch management. This includes both operating system updates and application updates.
These patches often fix critical security vulnerabilities, so keeping everything up to date is one of the easiest and most important things you can do. Endpoint security software also plays a key role. While Apple's iOS is a closed environment where apps only come from the App Store, Android is more open, making it more susceptible to malware. Antivirus and anti-malware apps are available for both platforms to add a layer of protection. You can also use content filtering to block access to specific websites or applications. What happens if a device is lost or stolen? That's where remote capabilities come in. Locator applications use GPS to pinpoint your device's location on a map in real time. If it's nearby, you can remotely play a sound to find it. If you can't get it back, you have the option to perform a remote wipe, which erases all personal data from the device. To prepare for this, always use remote backup applications. Mobile devices are perfect for cloud-based backups, which constantly save your data without you having to do anything. If your phone is wiped or you get a new one, you just log into your cloud account and your digital clone is restored. Finally, in a corporate environment, all of this is managed through policies and procedures. The most important tool is Mobile Device Management, or MDM. An MDM is a central server that allows administrators to set and enforce security rules for all phones, whether they are corporate-owned or personal devices under a Bring Your Own Device, or BYOD policy. Using the MDM, an admin can push out configuration profiles that force users to have complex passcodes, enable encryption, or even disable the camera when they enter a secure facility. To summarize the key ideas, secure mobile devices by hardening them with encryption and strong screen locks, keeping them updated with patch management, protecting them with endpoint security, preparing for loss with remote tools, and managing them centrally with an MDM.
Now that we've hardened our active workstations and mobile devices, what happens when it's time to get rid of them? Simply throwing a hard drive in the trash is a massive security risk. We have to make sure the data is gone for good. This is your rapid-fire review of Objective 2.9, Data Destruction and Disposal. First, let's look at physical destruction, which offers the highest guarantee that data is unrecoverable. For a small number of drives, you can simply drill holes directly through the magnetic platters, or even use a hammer. For large-scale operations, industrial shredders grind the drives into small, useless metal fragments. You can also use incineration to completely destroy the drive with fire. A more technical method is degaussing, which uses an extremely powerful magnet to completely erase the magnetic field on a drive's platters, destroying the data and the drive itself. But be very careful. Degaussing only works on magnetic hard disk drives, or HDDs. It is completely useless on solid-state drives and flash memory. But what if you want to reuse the drive? In that case, we turn to software-based methods. You can use a dedicated disk wiping utility, like the famous dban, which overwrites every single sector on the drive multiple times, making the original data unrecoverable. This is often confused with formatting, but they aren't the same. Let's break down formatting. Think of your drive as a huge library. A quick format is like ripping the card catalog out of the library and replacing it. All the books, your data, are still sitting on the shelves, just waiting for someone with the right tools to find them. This is why a quick format is insecure. A standard format, on the other hand, is like going to every single shelf and shredding every page of every book before installing a new card catalog. It overwrites every sector, securely erasing the data so the drive can be safely reused. Low-level formatting is even more thorough, but that's a process usually only done at the factory. For large organizations, destroying thousands of drives is a massive job, so they often outsource it to a specialized third-party vendor. When doing this, it's absolutely critical to get a certificate of destruction. This is a legal document that serves as an audit trail, proving that your specific drives were received and properly destroyed.
This certificate is essential for complying with legal and regulatory requirements, especially when dealing with sensitive, personally identifiable information, or PII. To summarize the key ideas, for maximum security, physically destroy the drive using methods like shredding or drilling. If you need to reuse the drive, perform a standard format or use a disk wiping utility, never a quick format. And when outsourcing, always get a certificate of destruction to verify compliance. We've secured our data at rest and even figured out how to destroy it safely. But that data is constantly moving across our networks. To be truly secure, we have to lock down the pathways it travels. This is your rapid-fire review of Objective 2.10, Securing SOHO Wireless and Wired Networks. We start with the router, the heart of the SOHO network. The very first thing you must do with any new router is change the default administrator password. Default logins are public knowledge, and leaving them unchanged is like leaving the key to your house under the doormat. Just as important is keeping the router's firmware updated. Firmware is the router's operating system, and updates contain critical security patches. Next, we control the traffic. Routers can perform IP and content filtering, allowing you to create deny lists that block specific malicious websites or even entire categories of content. A major security risk on SOHO routers is a feature called Universal Plug-and-Play, or UPnP. It was designed for convenience, allowing internal applications to automatically open ports on your firewall. From a security perspective, this is a nightmare. Always disable UPnP. To properly secure a network, we need to separate it into zones. For any services that need to be accessible from the internet, like a web server, you should place them in a screened subnet, also known as a demilitarized zone, or DMZ. The DMZ is like a secure reception area. Visitors can access it, but they can't get into your private internal network. For wireless security, start by changing the default SSID, which is the name of your network. While you can disable the SSID broadcast, this is just security through obscurity and doesn't actually stop a determined attacker. What really matters is encryption. You must be using, at a minimum, WPA2 and ideally WPA3. For visitors or less secure devices like IoT gadgets, always configure a guest network. This gives them internet access but keeps them completely isolated from your main trusted devices. Finally, we have the firewall settings. For your wired network, a critical best practice is to disable any unused physical network ports on your switches. An active open port in a conference room is an open invitation for an intruder to plug in. For services you need to make available, you'll use port forwarding. This maps a public port on your firewall to a specific internal IP address and port. Be careful. A port forward creates a permanent 24/7 hole in your firewall, so only use it when absolutely necessary. To summarize the key ideas, secure your SOHO network by changing default passwords and updating firmware. Control traffic by disabling UPnP and using a DMZ. And lock down access by using WPA2 or WPA3 encryption, disabling unused ports, and configuring a separate guest network. We've hardened our workstations, secured our mobile devices, and locked down our SOHO networks. But all that protection can be bypassed by the single most used application on any computer, the web browser. To complete our security posture, we must fortify this critical entry point. This is your rapid-fire review of Objective 2.11, Configuring Browser Security. The foundation of browser security starts before you even install it. Always download the browser directly from the developer's official website. Malicious versions are often distributed on third-party sites. To be absolutely sure your installer is legitimate, you can verify it with hashing. The developer provides a hash, like a SHA-256 string, on their site. You run the same algorithm on your downloaded file, and if the hashes match, the file is authentic. Once installed, keep it patched. Modern browsers update automatically, and these updates contain vital security fixes. Next, we have to talk about extensions and plugins. While they add great features, they have the same level of access to your system as the browser itself. This is a massive attack vector. Only install extensions from trusted sources like the official Chrome or Microsoft stores. A malicious extension can log your keystrokes, steal your passwords, and screenshot your data. To manage those passwords securely, use a dedicated password manager. It's an encrypted vault that stores a unique, complex password for every single website you use. This completely neutralizes the risk of password reuse. If one site is breached, the attackers can't use those credentials anywhere else. When you're browsing, your browser is constantly checking for secure connections using digital certificates. If you see an error like, "This connection is not private," it's a major red flag. It could mean the site certificate has expired, doesn't match the domain name, or was signed by an authority your browser doesn't trust. A common simple cause for this is your computer's clock being set to the wrong date and time. Inside the browser settings, you have several tools to control privacy. Keep the pop-up blocker enabled and only grant exceptions to specific, trusted sites. You should periodically clear your browsing data, especially the cache. The cache stores website data locally to speed things up, but it can become corrupted or outdated, causing issues. For true privacy on a public or shared computer, use private browsing mode. This ensures no history, cookies, or cache are saved to the local machine once you close the window. Finally, in a corporate environment, you'll often use a proxy server. This acts as a middleman, filtering all your web traffic. It can block malicious sites, scan for malware, and enforce access control. You might need to explicitly configure the proxy's address and port number in your browser. For another layer of privacy, you can enable secure DNS, also known as DNS over HTTPS. This encrypts your DNS queries, preventing anyone on the network from snooping on the websites you are visiting. To summarize, secure your browser by downloading from trusted sources, keeping it patched, and vetting all extensions. Use a password manager and pay attention to certificate warnings. Manage your privacy by clearing the cache and using private mode when needed. And in a corporate environment, you'll leverage tools like proxies and secure DNS.
Hey, really quick pause here. I know we're covering a ton of material right now. If you want a clear path to organizing all this, head over to TechVaultAcademy.com and grab our free A+ Success Toolkit. It's got a 6-week study roadmap and a readiness quiz to help you find your weak spots fast. And once you know your gaps, you can fill them with our Core 2 Mastery Bundle. It's packed with high-yield notes, practice exams, and yes, the Active Recall flashcards are ready to help you lock it all in. And you don't have to do this alone. You also get access to our free community, where thousands of students are sharing tips, asking questions, and keeping each other motivated. Link is down below. All right, let's get back to it. We've spent the entirety of Domain 2 building a fortress, focusing on proactive security to prevent bad things from happening. But in the real world of IT support, things still break. So now we pivot from prevention to reaction. Welcome to Domain 3, Software Troubleshooting. We're starting with the heart of it all, the most common problems you'll face in the Windows operating system. This is your rapid-fire review of Objective 3.1. First up, the most infamous error of all, the blue screen of death, or BSOD. This is a critical stop error, where the OS shuts down completely to prevent damage, usually due to bad hardware or a faulty driver. The screen will give you a stop code, which is your primary clue. If the system won't reboot, try booting to the last known good configuration or using System Restore. Next is degraded performance. If a system is running slow, your first stop is the Task Manager. Check the Performance tab for spikes and sort the Processes tab to find any applications that are hogging the CPU, memory, or disk. Also, make sure Windows is updated, the disk isn't full, and if it's a laptop, check if it's plugged in. Performance is often throttled on battery power.
Then we have boot issues, where the computer says operating system not found. The first thing to check is if a bootable USB drive was left plugged in. If not, the Windows Startup Repair tool can fix most common issues automatically. For more advanced problems, you may need to use the recovery console and run the command bootrec/rebuildbcd to manually rebuild the boot configuration database. Sometimes a system is just unstable, with frequent shutdowns or random application crashes. This often points to a hardware problem. Run a full hardware diagnostic, especially on the memory. You can also use the built-in System File Checker, or SFC, to scan for and repair corrupt Windows OS files. If you get a message that service is not starting, open the Services app. Check if the service has any dependencies, other services that must be running first. Also verify the account permissions for that service. If it's a Windows service, run SFC. If it's part of an application, your best bet is to reinstall that application. For application crashes, your primary tool is the Event Viewer, which logs every action and error in Windows. For a more user-friendly view, check the Reliability Monitor, which tracks an application's stability over time. Low memory warnings mean your RAM is full. Open Task Manager to see what's using all the memory. Windows manages this by using virtual memory, which is a paging file on your hard drive that acts as slow overflow RAM. You can check its configuration in your advanced system settings. If you get a USB controller resources are exceeded warning, it means you've plugged in too many complex devices for the controller to handle. The quickest solution is to simply unplug the device and try it in a different USB port, which may connect it to a separate controller on the motherboard. In a corporate environment, a slow profile load is almost always a network issue, caused by latency when syncing a roaming user profile. This is a problem for the domain administrator to solve. And finally, time drift. A computer's clock will naturally become inaccurate over time. To fix this, just make sure Set Time Automatically is enabled in the Windows Time and Language settings so it can sync with a time server. To summarize the key tools, for performance, use Task Manager. For boot issues, use Startup Repair and Boot Rec. For system file corruption, use SFC. And for application crashes, start with the Event Viewer and Reliability Monitor.
We've just covered the most common issues you'll face on a Windows desktop. But these days, our most used computers are the ones in our pockets. Troubleshooting mobile devices presents a unique set of challenges. This is your rapid-fire review of Objective 3.2, Common Mobile OS and Application Issues. Before we dive in, remember the universal first step for almost any mobile problem: turn it off and on again. A simple restart clears out temporary files and can solve a huge number of glitches with a clean slate. Let's start with application issues. If an app fails to launch, crashes, or is just slow and unresponsive, your first step is to force close it. On an iPhone, you'll swipe it off the screen. On Android, you'll use the Force Stop button in the app settings. If that doesn't work, restart the phone. If the problem persists, check for an update in the App Store, as it might be a known bug the developer has already fixed. As a last resort, uninstall and reinstall the app completely. What if an app fails to install or update in the first place? There's a simple checklist for this. First, check your storage. OS and app updates can be large, and you need enough free space. Next, check your connectivity. A stable, high-speed Wi-Fi connection is best. Then, check your payment method. Even free apps can require a valid payment method on file in the App Store. Finally, if it's a work device, check the device management policies, as the MDM might be blocking the installation. Now for the operating system itself. If the OS fails to update, the checklist is similar. You need plenty of storage space and a very stable, high-bandwidth connection. If your device is suffering from random reboots, this is a tougher problem. Start by making sure both the OS and all your apps are fully updated to rule out software bugs. You can also check the battery health in the settings, but frequent random reboots often point to a hardware failure which may require you to replace the device. Poor battery life is another common complaint. The number one cause is a weak cellular signal. When your phone is constantly hunting for bars, it drains the battery incredibly fast. If you're in an area with no service, just switch to airplane mode. The other major drains are an old battery that no longer holds a charge or having radios like GPS and Bluetooth on when you're not using them. Your phone's battery settings will show you exactly which apps are using the most power. For connectivity issues, whether it's Bluetooth, Wi-Fi, or NFC, the troubleshooting is straightforward. First, make sure the specific radio is enabled in your settings. If it is, try toggling it off and on again. If that doesn't work, restart the entire device. For Wi-Fi, you can also try moving closer to the access point or connecting to a different one to isolate the problem. Finally, what if your screen doesn't auto-rotate between portrait and landscape? This almost always has a simple solution. The phone's accelerometer detects the orientation, but there's a software lock that can override it. Check your phone's quick settings panel and make sure you haven't accidentally enabled the rotation lock. To summarize the key ideas, for almost any issue, start by restarting the device. For app problems, use the sequence force stop, restart phone, update app, then reinstall app. For update failures, check your storage and connectivity. And for most other glitches, a simple toggle in the settings, like turning a radio off and on again or disabling rotation lock, is often the solution.
While a simple restart or checking the rotation lock can fix many common mobile glitches, sometimes the problem is more malicious. Your phone contains your most sensitive data, making it a prime target for attackers. Now we're going to cover how to troubleshoot security issues. This is your rapid-fire review of Objective 3.3. First, let's look at the root causes of security problems. The number one risk is your application source. Installing apps from unofficial stores or websites is called sideloading. It's like buying medicine from a street vendor instead of a pharmacy. You have no idea what's really inside that package. Malicious apps are often disguised as legitimate ones, a technique called application spoofing. Another major risk is intentionally disabling your phone's built-in security. On Android, this is called rooting. On iOS, it's known as jailbreaking. Both give you complete control over the OS, but they also shatter its defenses and allow malware to run rampant. So how do you know if your device has been compromised? You look for the common symptoms. A classic sign is a sudden spike in high network traffic or receiving a data usage limit notification when your habits haven't changed. This could be malware sending your personal files to an attacker. Another symptom is degraded performance. If the phone is suddenly sluggish and restarting doesn't fix it, malware could be consuming all your CPU and memory in the background. You might also experience limited or no internet connectivity, as some malware blocks access to prevent you from downloading security updates. And of course, a sudden high number of ads popping up everywhere is a dead giveaway for adware. The outcomes of an infection can be severe. You might see fake security warnings, which are pop-ups that trick you into installing even more malware by claiming your device is already infected. Apps might start exhibiting unexpected behavior, like crashing or changing settings on their own. And the worst-case scenario is leaked personal files and data. So what's the solution? For minor issues like adware, an anti-malware scan might be able to find and remove the offending app. But if you have symptoms of a deeper infection or suspect your data has been leaked, the only way to be 100% sure the threat is gone is to perform a factory reset. This wipes everything from the device and restores it to its original, clean state. After a reset, and especially after a data leak, you must immediately change the passwords for all your cloud accounts that were synced to the device and enable multi-factor authentication everywhere you can. To summarize the key ideas, protect your phone by only using official app stores and never jailbreaking or rooting it. Watch for the symptoms of malware, like high data usage and slow performance. And if you suspect a serious infection, back up your essential data, perform a factory reset,
and then change all your passwords. We just finished securing our mobile devices, but now we need to return to the heavy lifters, personal computers. Just like phones, PCs are constant targets for attackers, but the symptoms of an infection can look a bit different on a desktop operating system. This is your rapid-fire review of Objective 3.4. First, let's talk about connectivity. One of the smartest things modern malware does is cut your lifeline. If your PC suddenly cannot access the network or browse the internet, it might not be a router issue. Malware often acts like a gatekeeper, locking the driveway so you cannot go to the store to buy the tools you need to remove it. By blocking your internet access, the malware prevents you from downloading antivirus updates or removal tools. In this scenario, you may need to boot from external media to clean the system. Next, we have the theatrical side of malware, scareware. You might see a desktop alert screaming that your antivirus has expired or that your computer is infected with 1,000 viruses. These are false alerts designed to panic you into calling a scam number or clicking a malicious link. They are a production, a fake emergency. If you see these, do not click them. Run a legitimate scan with your own trusted software. Another sign of a deep infection is when your files start acting strange. If system files are renamed, missing, or if you are suddenly denied access to your own documents, you likely have a serious breach. We also see issues with OS updates. Malware knows that updates patch security holes, so it will often block the update service to keep those doors open. If your updates act up, check your connectivity and firewall settings first. Now let's look at the browser, which is the most common battlefield. If you are seeing frequent, random pop-ups, even with a pop-up blocker enabled, you likely have adware. Then there is redirection. This is when you type in a search query or a web address, but the browser forcibly sends you to a completely different, often shady website. This is a classic sign of a browser hijacker. You might also encounter certificate warnings, saying your connection is not private. A web certificate is like a digital ID card. If the browser warns you, it means the ID card doesn't match the website name or the issuer isn't trusted. However, before you panic, check your computer's clock. If your date and time are incorrect, your computer will think the certificate has expired or is not yet valid, triggering a false alarm. Finally, watch for degraded performance. If your browser is sluggish and your CPU usage is stuck at 100%, a malicious website might be running a crypto miner in the background, using your electricity and hardware to make money for criminals. To summarize the main ideas, watch for malware blocking your network access to prevent you from getting help. Ignore fake scareware alerts and trust only your installed antivirus. If you see certificate warnings, check your system date and time first. And if you face browser redirection or constant pop-ups, scan for adware immediately. We've spent a lot of time deep in the trenches fighting malware and fixing boot errors, but in a professional IT environment, if you fix a computer but don't document it, technically it never happened. Welcome to Domain 4, Operational Procedures. We are kicking things off with Objective 4.1, where we cover documentation and support systems. First, let's talk about asset management. Think of your organization's hardware as treasure, and the CMDB, or Configuration Management Database, as the treasure map. It doesn't hold the physical equipment, but it gives you the exact coordinates, warranty status, and user history for every device. To link the physical world to this digital map, we use asset tags, stickers with barcodes that let you scan a device and instantly bring up its life story. But how do we get that equipment? We use the procurement lifecycle. Your nodes compare this to navigating an airport. You can't just walk on the plane, you have to pass through security gates. First is the request, then the purchase order, or PO, where we negotiate the deal, then the invoice, where the vendor asks for payment, and finally, accounting releases the funds.
Next is the IT Command Center, the ticketing system. Every issue needs a ticket. You need accurate user and device information, a clear description, and a severity level. Severity dictates priority. A broken mouse is low, but a server down is critical. If a ticket is too complex for Tier 1 support, we perform an escalation, handing it off to a specialized team like networking. And remember, your notes in the ticket must be clear. We document the resolution so the next technician doesn't have to reinvent the wheel. Now let's look at the rule books. For routine tasks, we use SOPs, Standard Operating Procedures. Think of an SOP as a cooking recipe. If every technician follows the recipe, the result is consistent every time. But when things go wrong, like a security breach or an accident, we file an incident report to create a legal history of the event. We also use checklists for onboarding new users and offboarding departing ones. Offboarding is an exam favorite. You must follow the checklist to ensure data is decrypted and backed up before you wipe the device, or that data will be lost forever. Finally, we have SLAs, or Service Level Agreements. These are contracts that define expectations, like a guarantee that a vendor will fix an outage within 4 hours, or else they face financial penalties. To summarize, use the CMDB to track your assets. Follow the procurement gates to buy them. Log every fix in the ticketing system, and use SOPs for routine tasks and incident reports for accidents. We just covered how to document your IT environment in Objective 4.1. Now we are going to talk about altering it. In technology, the only constant is change, but every modification carries the risk of disaster. To prevent chaos, we use change management. Think of this process as the air traffic control for your organization. Without it, changes would crash into each other, causing downtime and accidents. This is your rapid-fire review of Objective 4.2. It all starts with the request form. You can't just change things on a whim. You must financially justify the purpose. Are you patching a security hole or adding a new feature? Next, you define the scope and impact. Scope is how far the change reaches. Is it one laptop or the entire data center? Impact is the consequence, like taking the internet offline for the whole company to reboot a firewall. Not all changes are created equal. We use the mnemonic SNE to remember the 3 types. First is a standard change. These are low risk and pre-approved, like replacing a broken mouse. Next is a normal change. These are medium risk, like updating a core switch, and require the full approval process. Finally, we have the emergency change. This is high risk and happens immediately to stop a critical threat, like a 0-day vulnerability. Timing is everything. Changes usually happen during a maintenance window, a pre-approved time when usage is low, like Sunday at 2 a.m. However, during critical business times, like the holiday shopping season, we implement a change freeze, where no changes are allowed at all. Before you touch anything, you need safety nets. First, use a sandbox. This is a self-contained flight simulator where you can crash the plane safely without affecting the live network. Next, you need a rollback plan. If the change fails, this is your strict procedure to return the system to its original configuration. And don't confuse that with the backup plan. The backup plan is your plan B for the implementation itself, like having a flash drive ready in case the internet goes down while you are downloading a patch. Finally, approvals. The Change Control Board, or CCB, acts as mission control, reviewing the risk and granting permission to launch. But the mission isn't over until you have end-user acceptance. The people who actually use the system must confirm that everything works as expected. To summarize the key ideas, treat change management like air traffic control. Use the mnemonic to categorize changes as standard, normal, or emergency. Always test in a sandbox, have a rollback plan ready, and never close a ticket without end-user acceptance.
Backups are the ultimate insurance policy. If malware or hardware failure strikes, a good backup strategy can save the day. Welcome to Objective 4.3, Workstation Backup and Recovery. First, let's talk about the 4 backup types. Think of your data as a library. A full backup copies every single book in the library. It takes the longest time to run, but if disaster strikes, restoration is fast because you only need that one massive set. Next is the differential backup. On day 1, you do a full backup. On every subsequent day, you back up everything that has changed since that original full backup. To restore, you only need 2 sets, the full backup and the latest differential. Then we have the incremental backup. Again, day 1 is a full backup, but on subsequent days, you only back up the tiny changes made since the last backup run. This makes daily backups extremely fast, but restoration is slow and complex because you need the full backup plus every single daily increment in order. Finally, there is the synthetic full backup. This is like magic. The system takes your existing full and incremental backups and combines them internally to create a brand new full backup file without needing to transfer all that data across the network again. But backups are worthless if they don't work. You must perform backup testing to verify your files are readable. When restoring, you have 2 choices: in-place recovery, which overwrites existing files, or alternate location recovery, which saves the files to a separate folder so you don't accidentally destroy newer data. To organize all this, we use the GFS rotation scheme: grandfather, father, son. The grandfather is the monthly backup, the father is the weekly backup, and the son is the daily backup. And finally, to survive a disaster, follow the 3-2-1 rule. Keep 3 copies of your data total, store them on 2 different types of media, and keep at least 1 copy off-site, far away from your building to protect against fire or flood. To summarize, full backups are slow to create but fast to restore. Incrementals are fast to create but slow to restore. Use the 3-2-1 rule to ensure your data survives any disaster. Safety might sound boring until you fry a $1,000 component or, worse, hurt yourself. Welcome to Objective 4.4, where we cover the essential safety procedures for IT professionals. First, we have ESD, or electrostatic discharge. Think of static electricity like a coiled spring. It is harmless when sitting there, but deadly to electronics when it snaps. Here is a scary fact. You don't feel a static shock until it hits about 3,500 volts, but a computer chip can be destroyed by as little as 100 volts. That means you can fry a motherboard without ever feeling a thing. To stop this, we use equalization tools. The ESD strap connects your wrist to the metal chassis, keeping you at the same electrical potential as the device. We also use ESD mats to stand on or place equipment on. When storing parts, use anti-static bags, specifically the silver ones that shield against discharge. And always, always handle components by the edges. Never touch the chips directly. Next is electrical safety. The number 1 rule: disconnect the power source before opening anything. But be careful. Even when unplugged, some components store residual power. Think of a capacitor inside a power supply or laser printer, like a sponge. Even after you turn off the faucet, the sponge still holds water. These components hold electricity and can shock you. If you see a high-voltage component like a power supply, do not open it. Replace the whole unit. And a critical warning: never connect yourself to the building's electrical ground. If the building has a fault, you become the path of least resistance.
Then we have personal safety. When lifting heavy servers, protect your back by lifting with your legs. Use safety goggles when working with batteries or chemicals, and use an air filter mask when dealing with toner dust in printers. Also, watch your feet. Messy cables are a major trip hazard. Use Velcro or zip ties to bundle them up. Finally, let's talk fire safety. Electronics and water do not mix. Data centers use dry chemicals like FM200 or carbon dioxide to suppress fires, never water. If a device catches fire, your first move is to cut the power. To summarize, use an ESD strap to protect the chips. Unplug the power to protect yourself. Watch out for residual power in capacitors, and use dry chemicals, not water, for electrical fires. We've covered safety procedures for people and equipment. Now we turn to the environment itself. Objective 4.5 is all about managing the space your IT equipment lives in, handling hazardous materials, controlling the climate, and managing power. First, let's talk about the MSDS, or Material Safety Data Sheet. You might also see it called the SDS, or Safety Data Sheet. They are exactly the same thing. Mandated by OSHA, this document is your cookbook and first aid manual for hazardous items like toner and batteries. It tells you exactly what is in the product and how to safely handle a spill or fire. When you are done with these items, you can't just throw them in the trash. Batteries and toner cartridges must be recycled or disposed of at designated hazardous waste facilities. Many manufacturers include return labels right in the box to make this easy. Next, we have environmental controls. Computers generate heat, so temperature control is obvious. But humidity is a balancing act. Too low and you risk static shock. Too high and you risk condensation or corrosion. The target Goldilocks zone is around 50% humidity. For dust, keep the area ventilated. If a PC is clogged with dust, take it outside and use compressed air. Never use a standard vacuum inside a case, as it generates static. Finally, let's talk about power. We face surges, sags, and outages. A UPS, or uninterruptible power supply, uses a battery to keep systems running during an outage. There are three types: standby, which switches over when power fails; line interactive, which fixes voltage drops; and online, where the device runs off the battery 100% of the time for zero delay. If you don't need battery backup, you still need a surge suppressor. This absorbs voltage spikes. When buying one, look for three numbers. A high joule rating, over 600 is best, a high amp rating, and a low voltage let-through rating. Remember, lower let-through leads to longer life. Ideally, you want 330 volts or less. To summarize, read the MSDS for hazards. Keep humidity around 50%. Use a UPS for backup power, and choose a surge suppressor with a high joule rating and low let-through voltage. We've secured the environment and managed power. Now we move to the legal and procedural side of IT. Welcome to Objective 4.6, covering incident response, licensing, and privacy. This is where technology meets the law. First, let's talk about incident response. When a security breach happens, your goal is to identify, report, and preserve evidence. The golden rule here is the chain of custody. Think of this like a tracking number for a package. You must document exactly who touched the evidence and when, or it becomes useless in court. For digital evidence, we use hashes to prove the data hasn't changed. When collecting data, you must follow the order of volatility, or OOV. Volatile data disappears quickly,
like sand blowing off a castle. You must capture the most volatile data first, like CPU registers and cache, before moving to less volatile data, like the hard drive or backup tapes. And never just copy files. Make a bit-by-bit image of the entire drive using a write blocker to ensure you don't accidentally alter the evidence. Next, let's cover licensing. The EULA, or End User License Agreement, is that long contract you click I agree to. It dictates how you can use the software. In business, we use different license types. A per-seat license is for one specific person. A concurrent license allows a set number of people to use the software at the same time. And open source software, or FOSS, gives you the source code to modify, unlike closed source software. Then we have confidentiality. An NDA, or non-disclosure agreement, is a contract that protects trade secrets. If both sides share secrets, it's called a mutual NDA. Finally, we have regulated data. You must protect PII, personally identifiable information like Social Security numbers. In healthcare, we protect PHI, or protected health information, mandated by HIPAA. And for credit cards, we follow PCI DSS standards. To manage all this, companies use an AUP, or Acceptable Use Policy. This document limits legal liability by defining exactly what employees can and cannot do with company technology. To summarize, maintain the chain of custody for evidence, collect volatile data first, understand your licenses like EULA and FOSS, and strictly protect regulated data like PII, PHI, and credit card info. Fixing the computer is only half the job. If you fix the issue but alienate the user, you have failed. Welcome to Objective 4.7, covering communication techniques and professionalism. This is where you build your reputation and career. First, let's talk about your presence. Your attire is your uniform. Whether it's formal or business casual, it sets the tone. When you speak, avoid jargon. You are the translator, the bridge between the technical world and the client's world. Don't say, the DHCP scope is exhausted. Say, we're freeing up space for more devices to connect. And always project confidence. A positive attitude is infectious, especially during a crisis. Next is listening. We have a bad habit of interrupting because we think we know the answer. Stop. Use the mnemonic LAST. Listen to the entire story, ask probing questions, stop interrupting, and take notes. This allows the customer to vent and feel heard. Also, clarify their statements by repeating the issue back to them, like a mirror, to ensure you both understand the problem. Then we have managing the interaction. Be on time. If you are late, call. Avoid distractions like texting or personal calls. If you face a difficult customer, do not be defensive or argumentative. Instead, be a teacher. Educate them without being judgmental. Finally, managing expectations. Expectation is reality. If a repair takes 2 weeks, tell them up front. Communicate the status proactively so they don't feel forgotten. Offer clear repair or replacement options, explaining the pros and cons of each. And when the job is done, follow up to verify satisfaction. This catches any small issues that might have slipped through the cracks. To summarize, dress professionally and avoid jargon. Listen actively without interrupting. Manage difficult situations with empathy, not defensiveness. And always follow up to ensure the customer is 100% satisfied. We have learned how to talk to people. Now we need to learn how to talk to computers. Welcome to Objective 4.8, the basics of scripting. A script is simply a digital recipe, a set of instructions that automates boring, repetitive tasks so you don't have to do them manually. First,
Let's learn the languages. In Windows, the classic command line uses batch files, which end in .bat. But for modern system administration, we use PowerShell, ending in .ps1. PowerShell is powerful, using commandlets to manage the entire OS. For general Windows tasks like Office automation, we have Visual Basic Script, or .vbs. If you are in Linux or Unix, you'll use shell scripts, ending in .sh. A key identifier for these is the shebang or hashbang symbol at the very start of the file. For web browsers, we use JavaScript, or .js, which handles interactivity. And for cross-platform automation that works on Windows, Mac, and Linux, the king is Python, ending in .py. So why do we script? The biggest use case is automation. We use scripts to restart machines remotely, update software, or remap network drives when a user logs in. Scripts are also critical for automated backups, ensuring data is saved every night without a human needing to click a button. However, scripts are dangerous. Because they execute commands quickly across many systems, a mistake spreads fast. A bad script can unintentionally introduce malware to the entire network or crash systems by mishandling resources like RAM. Always test your scripts in a sandbox before deploying them and have a rollback plan ready. To summarize, use .bat and .ps1 for Windows, .sh for Linux, and .py for cross-platform tasks. Scripts automate updates and backups, but must be tested carefully to prevent widespread crashes. We have automated our scripts. Now let's control the machines themselves. Welcome to Objective 4.9, Remote Access Technologies. This is how you fix a server in London while sitting at a desk in New York. First, let's look at the GUI tools, which let you see and control a desktop. The big player here is RDP, or Remote Desktop Protocol. It's built into Windows and listens on TCP port 3389. Memorize that port, 3389. Another option is VNC, which is open source and cross-platform. And for virtual machines, we use SPICE. Think of SPICE as a fiber optic cable for VMs. It's optimized for fast graphics and smooth video playback. Next, we have the command line tools. If you need to configure a router securely, you use SSH, or Secure Shell. It runs on TCP port 22. SSH is critical because it encrypts everything. This is the opposite of the older Telnet, which shouts your password in plain text across the network. Never use Telnet. Always use SSH. To connect securely over the public internet, we use a VPN, or Virtual Private Network. A VPN creates an encrypted tunnel between your laptop and the corporate office. It uses a VPN concentrator to encrypt and decrypt the data, keeping it safe from prying eyes on the public web. For managed service providers who handle hundreds of clients, we use RMM, or Remote Monitoring and Management. This is a centralized dashboard that controls everything. Because it's so powerful, RMM tools are prime targets for hackers. You must secure them with MFA, or multi-factor authentication. Finally, for Windows admins running scripts remotely, we use WinRM, or Windows Remote Management. Security is paramount here. Remote access tools are open doors. Hackers scan for open ports like 3389 constantly. Always use encryption, like VPNs and SSH, and enforce MFA to prevent brute force attacks. To summarize, RDP uses port 3389 for desktops. SSH uses port 22 for secure command lines. VPNs encrypt data over the internet. And tools like RMM and WinRM allow for centralized automated management. We have covered securing the network and managing procedures.
Now we explore the most rapidly evolving frontier in IT, artificial intelligence. Welcome to Objective 4.10, where we break down the basic concepts of AI. The goal of AI is to create technology that can meet or exceed human intelligence. Think of AI as a digital brain apprentice. It learns, infers, and reasons based on the data you feed it. We integrate AI into everything. It creates generative content like images and video, summarizes thousands of emails in seconds, and sifts through terabytes of security logs to find threats hidden from human eyes. But AI has a dark side. You must understand the policies around inappropriate use. The most dangerous is fraud, specifically deep fakes, where AI impersonates a real person. There is also plagiarism, where students use AI to write papers without citation. And ignorant code, where developers generate application code they don't understand, potentially introducing bugs or vulnerabilities. Even when used correctly, AI has limitations. The first is bias. If you feed the AI flawed data, like a resume dataset dominated by men, it will learn that bias and unfairly reject female applicants. It acts like a funhouse mirror, reflecting back a distorted reality. The second limitation is hallucinations. This is when the AI is confidently incorrect. It might look at a cloud and swear it's a dog, or invent historical facts that never happened. Finally, we must choose between public and private AI. Think of public AI, like ChatGPT, as a public library. It has massive amounts of knowledge from everyone, making it very accurate, but it is open to the world. Using it carries a high security risk because sensitive data you type in, like passwords or company secrets, might be exposed to others. Private AI, on the other hand, is like a company vault. It is secure and controlled, but it only knows what you put inside, limiting its scope. To summarize, AI is a powerful tool for automation and analysis, but watch out for bias and hallucinations. Avoid unethical uses like deep fakes. And remember, public AI offers knowledge but risks privacy, while private AI offers security but limits scope.